Imagine, if you will, an endless expanse of space, a universe so vast that our minds struggle to comprehend it. It's a realm where the concept of distance takes on a completely new meaning, where the word infinity begins to make sense. We, humans, reside on a tiny blue dot, a speck of dust in the cosmic ocean, within a galaxy we call the Milky Way. But our galaxy is just one among an estimated 2 trillion galaxies in the observable universe. Yes, you heard it right, 2 trillion galaxies, each teeming with an average of 100 billion stars. Now, let's try to grasp this mind-boggling scale. Imagine if every grain of sand on every beach on Earth represented a single star. Even then, the total number of stars in the universe would surpass the number of those sand grains. It's a number so large that it's beyond human comprehension. And each of these stars, just like our sun, could be the center of its own solar system, potentially hosting orbiting planets. Some of these planets might be icy worlds, others might be gas giants, and yet others, rocky planets like our Earth. The sheer number of stars suggests that there could be more planets in the universe than grains of sand on all the beaches on Earth. Now consider this. If even a fraction of these planets are located in the habitable zone, the region around a star where conditions might be just right for liquid water, the key ingredient for life as we know it, the odds of life existing elsewhere in the universe increase dramatically. So, in the grand scheme of things, our Earth, our solar system, and even our galaxy are just tiny pieces of an unimaginably vast cosmic puzzle. And in this vast universe, the possibility of other planets seems not just likely, but inevitable. The quest to find planets outside our solar system, known as exoplanets, is no easy task. But why is it so challenging? Firstly, let's consider the sheer scale of our universe. With billions of galaxies, each containing billions of stars, the hunt for exoplanets is akin to finding a needle in an insurmountably vast cosmic haystack. Now, add to this the fact that these planets do not emit their own light, but merely reflect that of their host star. It's as if we're trying to spot a tiny firefly hovering next to a dazzling spotlight from miles away. But against these staggering odds, astronomers have developed ingenious methods to detect these elusive worlds. One such method is the transit method. Imagine you're watching a distant star, and suddenly its light dims ever so slightly before brightening again. This minute dip in brightness could be the result of an exoplanet passing in front of its host star, blocking some of its light. By observing these transits, astronomers can not only detect the existence of an exoplanet, but also glean valuable information about its size and orbital period. Another effective technique is the radial velocity method. This exploits the fact that a star doesn't remain perfectly still when it has planets orbiting around it. Instead, it wobbles slightly due to the gravitational tug of its planets. This wobble alters the star's light spectrum, creating a Doppler shift that astronomers can measure to infer the presence of an exoplanet. However, these methods come with their own set of challenges. For instance, the transit method requires the planetary system to be perfectly aligned with our line of sight, a scenario that is more the exception than the rule. Similarly, the radial velocity method works best for large planets in close orbits, potentially overlooking smaller, Earth-like planets in the habitable zone. Despite these challenges, astronomers have managed to identify thousands of these distant worlds. Their tireless efforts and innovative techniques are gradually unveiling a universe teeming with diverse and intriguing exoplanets, fueling our curiosity and broadening our cosmic horizons. The first exoplanet was discovered in 1992, a momentous occasion in the history of astronomy. The planet, named PSRB 1257+12b, orbits a pulsar, an extremely dense, rapidly spinning star that's the remnants of a supernova. This discovery was a breakthrough, a testament to our technological advancement and insatiable curiosity. It was like opening a door to an unexplored world, a world beyond our solar system, teeming with possibilities. For centuries, we had speculated, dreamed, and wondered if other planets existed outside our solar system. And in 1992, we finally had our answer. The discovery of PSRB 1257 plus 12b was just the beginning. In the following years, the floodgates opened and a wave of exoplanet discoveries followed. Today, we know of over 4,000 exoplanets, each one unique and intriguing. Take, for instance, the exoplanet named HD 189733b. This gas giant, similar in size to Jupiter, is a scorching hot world where it rains glass sideways in howling 7,000 km/h winds. Or consider WASP-12b, a planet so close to its host star that it's being torn apart and devoured. Then there's Kepler-22b, the first known extrasolar world to orbit within the habitable zone of its star, where conditions might be right for liquid water, a vital ingredient for life as we know it. And let's not forget about Gliese 667cc, an exoplanet located in the habitable zone of its star, where surface temperatures could be similar to Earth's. These exoplanets, and many more like them, are a testament to the diversity of the universe. They challenge our understanding of planetary systems and inspire us to imagine worlds vastly different from our own. The discovery of these exoplanets has not only expanded our knowledge of the universe, but also sparked a profound question. Are we alone? Every new discovery, every strange and fascinating world brings us one step closer to answering that question. As we continue to explore the cosmos, we may find that the universe is far more diverse and interesting than we ever imagined. The discovery of these exoplanets has led us to question if we are alone in the universe. One of the most exciting aspects of finding exoplanets is the possibility that they could harbor life. And not just life as we know it, but perhaps even forms of life that are beyond our current understanding. Life as we understand it on Earth requires certain conditions. Water is one of the most critical components. It's the universal solvent, the medium in which biochemical reactions occur, and it's essential for all known forms of life. But water alone isn't enough. Life also needs a suitable atmosphere, one that can provide the necessary gases for respiration and protect the planet from harmful radiation. And then there's the concept of the Goldilocks zone. It's not about bears and porridge, but about finding a planet that's just right. Too close to the star, and the planet would be too hot for life as we know it. Too far, and it would be too cold. The Goldilocks zone is that sweet spot where a planet could have liquid water on its surface, not too hot, not too cold, but just right. But let's not limit ourselves to life as we know it. What if there are life forms out there that thrive in conditions we would find inhospitable? What if there are organisms that drink sulfuric acid for breakfast or breathe methane? The universe is a vast place, and we're just beginning to scratch the surface of what's possible. Finding life on exoplanets isn't just about satisfying our curiosity. It's also about understanding our place in the universe. Are we alone, or is the universe teeming with life? We don't know the answers yet, but every new exoplanet we discover brings us one step closer to finding out. So we continue our search, scanning the skies for planets that might just have the right conditions for life. We're looking for our cosmic neighbors, for other worlds that might be teeming with life forms as diverse and wonderful as those on Earth. The quest to find life on exoplanets continues to be one of the most thrilling aspects of astronomy. And who knows? One day, we might just find that we're not alone in this vast universe. The exploration of exoplanets is just beginning. What does the future hold for this exciting field of study? The future of exoplanet exploration is as vast and mysterious as the cosmos itself. Yet, with every passing day, we're making strides towards understanding these distant worlds, thanks to the continuous evolution of technology and our insatiable curiosity. In the years to come, we will witness the launch of several ambitious missions, each designed with a unique objective. The James Webb Space Telescope, set to launch soon, has been designed to peer into the distant reaches of the universe and will undoubtedly uncover new exoplanets. Its infrared capabilities will allow us to study the atmospheres of these distant worlds, providing us with clues about their potential habitability. Furthermore, the Plato mission, a project by the European Space Agency, is set to revolutionize our understanding of exoplanets. It aims to find and study a large number of Earth-like planets around Sun-like stars, and its advanced technology will provide us with unprecedented insights into these celestial bodies. As we continue to develop and refine our technology, the possibility of human exploration of these distant worlds becomes more than just a science fiction dream. While it may be many decades, even centuries, before we can set foot on an exoplanet, the groundwork is being laid now. The study of exoplanets is not only about advancing our scientific knowledge, but also about understanding our place in the universe. Moreover, the search for exoplanets is also a search for life. As we continue to discover planets in the habitable zone, the potential for finding extraterrestrial life increases. It's a thrilling prospect that drives us forward, fostering the spirit of exploration and discovery that is inherent in all of us. The future of exoplanet exploration is bright, filled with endless possibilities and countless discoveries waiting to be made. It's a journey that we are all a part of as we venture further into the cosmos, seeking answers to our most profound questions. As we continue to explore the universe, who knows what fascinating discoveries await us?